I would just like to demonstrate and explain my picture-in-picture sniper scope material here, as you can see. So I'll go through all the parameters one by one. I'm going to skip the camera settings first and explain them later. So we'll start with the inner ring. So the inner ring is that black blue ring you see on the inside of the scope when I move around like this. Now there's a few settings you can change here. I'll first change its radius a bit smaller so we can actually see it. Keep it right there. So radius is self-explanatory, it just changes the radius of the sphere or the circle. The density is how hard this edge is. So right now it seems very soft. I can make it even softer by lowering this number, or I can make it very hard by increasing this number. You can see it's a very hard edge now, so I'll keep that at default. Inner rim size, that is this blue lighting effect you can see here. You can change the size of it. I kept the numbers very low, otherwise it just looks ridiculous. So you can make it 0 so you can't see it, or around there. You can change the opacity of that inner rim, and then its color. All very self-explanatory. The next thing is lens distortion. So if I look at this tree in the distance here, the one way back there, you can see it looks fairly straight. So I look up and down. When I start moving to the right, notice how that tree now starts warping as it gets closer to the edge of the scope, and obviously it works the other way around as well. That's what this lens distortion effect does. So it also has these density and radius values, so if I lower the radius, you can see the effect changes a bit, and if I increase the density now, you can see there's a very hard edge of the distortion over here. It's hard to see when you're not moving, but once you start moving you can clearly see it. And so if it makes the radius slightly bigger now, you cannot even see it because now it's behind the side picture and you can't see it. So if I just lower it a bit, I can see it's on the edge now. That also looks kind of nice, just depends on what you want. The default, I'll keep these at defaults. So the scale, that just means how much it's going to distort the image. So if we take a look at this tree again, if I put it around there, if I increase the scale, you can see the tree just starts distorting a lot. I kept this at a maximum of 10 because at this point it just looks ridiculous. So let's keep that value at 1 for now. And obviously a value of 0 will disable the effect entirely. Now there's no lens distortion. Let's put that back up to 1. This normal, the BU sphere normal, that is the outside of this lens. You can't really see it here, but if I open up the preview here, you'll see it a lot clearer. If you look at this plane, it almost appears to be spherical, but it's not at all. It's just a flat plane. But by using this checkbox, you can make it either a flat plane, so now it's a flat plane over there, or you can make it look spherical. I like this effect. The scratch intensity, so you can have scratch effects on the lens. If we bump this up to 1, you can see it looks quite rough, and if I close this down a bit again and scope in, you'll see it. It looks quite nasty. So you can change this. Basically just controls the opacity of these scratches. In the pack I've included 4 maps you can use. Each looks slightly differently. I'll just keep the 4th one. You can change the scale, so it quite literally just scales the texture on both axes to whatever you like. I'll just keep it at 1. And sphere scale will be again easier to show on the preview here. That just changes the scale of that sphere effect. Now I recommend keeping it at 1, that way it looks the best. Let's move this out of the way. Okay, so I'm just going to turn on the scratch. Now we get to outer ring. Now, outer ring is that black effect that you see moving around the front of the lens as I move around. If I unscope and scope back in with that black sphere that moved out of the way, that's the outer ring. So you can flip the axes, both X and Y, if you want to. So note when I aim to the right, you can see it moves in from the right, and if I aim left, it comes in from the left. You can flip that. So if I aim right, it's going to come in from the left now. And then Y is the same thing. If I look down, it's going to come from the top. Up, it's going to come from the bottom. If you flip that, you can see it flips those effects. The density, again, that's just how sharp that ring is. So if I just make it a lot harder, you can see the ring is much harder than it used to be. The radius, self-explanatory again, it's just the radius of that circle. Now the offset, that's basically how sensitive this ring is to motion. So note when I play this firing animation, you can barely see the ring moving in and out in front of the picture. But if I increase this offset to say maybe 1, you can see it it moves a lot more. It's a lot more sensitive to movement. So that's what the offset value does. If you make this 0, that doesn't exist anymore. It doesn't move at all. It stays in the center and it won't move according to the lens's position relative to the camera. So I like 0.4. It's quite a nice value. Now this last parameter here, outer ring radius rate of change. So note if I move the scope further away from the camera, the radius of the sphere is going to decrease. You can see that. Now this variable controls how fast this sphere's radius changes, but it's lying, because you would think a higher value would make it change faster, but in reality it's the other way around. So note how fast it's changing now. If I change this down to 6, you can see the rate of change has actually gone up, but the value went down. So it's just something to keep note of. But I like it at 10. Just make that stop. So scope depth, can't see that here. Let me increase the window. Scope depth, that's what gives the illusion of the side picture being way down here at the bottom end of the scope and not right at the front here of the lens, as well as the reticle. This controls the render texture and the reticle. The higher this value, the further down the scope the side picture will appear, but keep this value as low as possible, because the further down you move the side picture, the more you're going to have to scale that texture, and scaling the texture means it's going to look blurry. So you want to keep this as low as possible while also maintaining a decent looking effect. Render texture scale, so that's the texture the scene capture component is rendering to. You have a few settings to play with here, so you can obviously change the scale of the side picture, but here you can see, like, as I increase the scale it becomes more blurry, and you want to avoid that. So I recommend keeping this value as low as possible as well, but not too low. So if I make this low, you can obviously see these visual artifacts, and you want to avoid that. So you can play around these values to see what you like. The texture tint, it just gives an overall color tint to the side picture. You can see here, if you look into these trees on the right here, they seem a lot more cooler in kind of a blue tone, whereas the side picture is more warm and orange. You can change that color to whatever you want, so light blue. You can easily see it when it's light blue. And then you can change how much of that blue shines through. So if you increase the alpha value here to 1, it's completely blue now. Obviously you don't want that, so keep this down to what it was at 0.5. I quite like that. Let's keep it back at the warm color. The render texture, that's the texture your scene capture component would be rendering to. So you just need to put that in there. Now the reticle. I have included 10 reticle textures you can use. Each were made specifically for this material. So that's, I'm not going to showcase all of them, I'll just explain what they look, how they work. I like this one over here. So the reticle color, that would be these black parts here that you can see, these dots and these lines over here. You can change that color to whatever you like. You can make it green just to show. The emissive part, that's this red part here. Each reticle has its own emissive part and non-emissive part. You can also change that to any color you like. The emissive part is what appears to be glowing, and you can change how much it glows with this value here. Obviously that looks a bit ridiculous when it's glowing that much, so I'd keep it at 2. Here you can change the reticle texture to any one of the 10 I included, and you can also change the scale of the reticle. You can make it really big or really small. keep them at their default values. Smudges, that's kind of like the dirt on the lens. And this would again would be easier to show in the material preview here. So let me put up the opacity to 1. So this can give the, you can add fingerprints or just dirt. You can change the color of it, whatever you want. You can also see it taking effect here. You can change the density. So this also works with a sphere where the radius can change in the density, and the easiest way to show that would be with one of the other dirt textures that are included. So like this one. If I make the density very high, like 50, and then as I increase the radius, you can see this is a circle moving from the center outward. So you can control how much of the lens gets affected by the dirt. And then obviously lowering the density will make it look a lot better. So it looks softer. So if I increase the radius just a little bit more. And if I now scope in on the right here, you can see the dirt's only around the edges of the lens. So it doesn't obstruct the side picture too much. So obviously you can play with these values. The scale quite literally just scales the texture on both axes, X and Y. And all of, not all of them, the first one you shouldn't scale too much because it's not a tileable image. But the other masks, they're all noise textures, so you can scale them to as much as you like, then it'll be seamless. Like so. And that's it there. I'll just keep the opacity down to 0 to showcase the rest, and then all that's left is the roughness and specular values of the lens. So with a roughness value of 1, it's not reflective at all. You can actually see it easier over here. It's non-reflective. Turn that down to 0, you can see it reflects a lot more. And the specular value, I wouldn't turn this up too much because you start seeing visual artifacts on the lens here. So right here, you can see this part here. The higher the specular value, the more you start seeing this artifact. So I'll just turn that back down to what it was to make it less obvious. And that's pretty much it. So I just want to explain what the camera settings do. They directly affect the outer ring. And the reason for that is because the outer ring is controlled by the camera's relative position to the mesh that this material gets applied to. So in the case here where we're using the mesh that I've provided, it's fairly simple. So to test this, you need to apply a material called m_test_ins. It's included into the pack. And I'm going to go in game now and you can see what that does. When I aim down sight, you can see the X value and the Y value are 0. That means that the mesh is exactly in the center of the screen on the local X and Y plane. But the Z value is 5. That means that the mesh is exactly 5 units away from the camera. So in your material, you're going to add that value here at Z offset. It's already set to 5. That basically, like I said, it controls the outer ring. So if I stop this now and quickly add the material back, if I aim now, you can see the ring comes back directly to the center of the mesh. If I offset the X value, let's say by, I don't know, by 2 units, you can see the outer ring got offset. So that's why it's important that you get those values right. But when you're using my mesh that I've included, you're only ever going to have to worry about the Z value, how far away the mesh is from the camera. This becomes more problematic when you're using your own scope mesh and assigning the material onto your own scope mesh. So in this example here, I'm going to quickly just hide my mesh that I've made. And this, I'm going to assign that test value to now. Or actually, I'll keep the picture-in-picture one on it so you can see why this becomes important. If I play now, you'll notice you can't see anything. And that's because the outer ring is wildly offset. And why is that? That's because the origin point of the scope mesh is way down here, unlike the mesh that I've included where the origin point's right over there. Because the camera's still here, it's now wildly offset. So how do you figure out what these values are? And that's again where you use the test material that I've included. So now, when I aim down sight, you can see fairly different numbers now. In X again, the mesh is exactly in the middle of the screen on the X axis, but on Y it's 3 units off, and in Z it's 23 units off now. And that makes sense, because if you think about it, that meant that the origin point was 23 units away from the camera, and it was 3 units downwards. You can see here it's not exactly in the middle anymore, it's down by 3 units. So those values that we got there, you need to go input them into the master in the material here. So for X it was 0, for Y it was 3.55. So you have to put in the number multiplied by -1. So if we take 3.55 multiplied by -1, you need to put in that value that you get there, multiplied by -1. And on the Z value, you just put in that value straight as it is, 23.17. 23.17. So now, if we stop this, and we go assign the picture-in-picture material again, and I aim down sight, there, you can see the outer ring moved out of the way as it should, and it works perfectly now. You can also see now that the inner ring's radius is off and the reticle scale is slightly off. That's just because we're using the mesh, the scope mesh as material instead of the flat plane that I've provided. Another another defect of this is now the rate at which the outer ring changes, its radius changes, is also affected because the origin point of the mesh is further away. And there's another nasty side effect, which is the lens distortion. Now you can't exactly see it here, so let me quickly increase the inner ring radius. Let's make it 2. You can see there is quite visible distortion when using this, and that is because the master material uses the bump offset node. And the problem with that is that this mesh here, if I just quickly move back my own lens, the scope mesh that has the lens attached to it, you can see this lens is very much curved. It's curved a lot. And that's what's giving this nasty lens distortion. It just doesn't look all that nice. And so that's why I would recommend, or highly encourage you in fact, to use this plane that I've provided. It gives the best looking scope.